The other common way that we use to measure angles is called radians. Degrees are used a lot in everyday world, in a lot of jobs, in a lot of mechanics and carpentry. People use degrees and they're familiar. However, 360 is entirely arbitrary, and the only reason we use it is because it has a lot of factors. Specifically, we can divide 360 by 1, 2, 3, 4, 5, 6, not 7, but 8, 9, 10, 12, 15, 18, 20, 24, 30. We can keep going. 36, 40, 45, 60, 72, and 90, as well as multiples of those, like 120, 180, and 360. This insane number of factors makes it really easy to split a circle up into fractions of thirds or tenths or 18ths, if that's what we want to do. It's a common misconception that 360 was chosen because people thought there were 360 days in a year. That's just not true. In fact, there are some civilizations where a circle is broken down into 400 parts, and each 90-degree angle can actually be described as 100 gradians, but those aren't very common. Instead, we're going to focus on defining a way of measuring angles that isn't arbitrary and has direct applications within mathematics. That measure is called the radian, and it starts with the definition of the circumference of a circle. We know that the circumference of a circle is 2 times pi times whatever the radius of the circle is. This will give us the distance all the way around the circle. If we want to measure an angle in radians, we start, once again, with a circle with a vertex right at the center and a ray pointing in one direction, describing our initial side. When we rotate our terminal angle to whatever measure we want, all we need to do is look at the distance that we went around the circumference of the circle, and that will be the measure in radians. Keep in mind, this only works if this is a unit circle where the radius is 1. So in these examples here, as long as the radius of this circle is 1, then the measure of this angle is just how far we walk along the circumference of the circle. If we have a radius of 1 and we walk 2 units along the circumference of the circle, then we would say we're moving 2 radians, and that would be the size of this angle here. As we know, there are 2 pi radians in an entire circle, and therefore in a unit circle, going all the way around represents a distance of 2 times pi times 1, or 2 pi radians, and half of a circle represents a measure of pi radians, which we can see marked on this graph here as a little bigger than 3. So how many radians would it be if we rotate one full circle? Once again, let's draw our unit circle, our vertex, and our initial angle. If we make one full rotation along the outside of that circle, and this unit circle has a radius of 1, then the number of radians of this angle is just the circumference of that circle, and it's 2 times pi times 1, which is just 2 pi radians. In class, we will explore what 1 radian looks like and use that to extrapolate sizes of other radians. We'll talk about how to convert between degrees and radians and back, and discuss why radians are useful and where we use them in math.